Hello guys, welcome to my channel, and if you are new to this channel, please subscribe to my channel, like the videos, and also press the bell icon so that whenever in future I'll upload my new videos, so you will get notified at first. And please share my videos to your friends and please support me. So I'm back with another new video of my interview series questions. So I'll pick one question from those questions that were asked in various companies, various FAANG companies, like Google is one of them. And I'll explain that problem, and I'll also tell the two approaches. One is brute force approach and one is the optimized approach for that single problem, which you can propose in any interview. Like if you have an interview, you have asked that particular question, then you can propose these two solutions. Okay, so let's get started. Yeah. So the question is the unique paths, unique grid paths. So the question is like that. You'll be given a grid. It can be any type, any grid. It can be any 2D grid, like it can be 2x2, it can be 2x3 grid, or a maze. So you have to find the number of paths by which you can come to the end point of the grid. Like suppose you are at the starting point of the grid, suppose you are in the 0,0 cell. Now you want to come to you have to tell the interviewer the total number of ways how you can approach or how can get to the position at last position in the last cell of the grid. So there is a same type of question in the lead code medium. So I'm showing the screen and just saying the question. Okay. Okay, cool. So here is the question. So the question is unique paths, as I told. Its name are different in different editors and different platforms. So in LeetCode, its name is unique paths, and the same type of questions, same type of logic, it can be used in any type of interviews of that I'll be using today. So the question is like that the question mentioned it, a robot is located at the top left corner of a m into m cross n grid, like mark start in the diagram below. Like you can see in the diagram that, as I told, that in the 0,0 column there will be a you will be a starting point, and you have to tell the total number of paths to reach this end position, that is the end cell. Like suppose this have a 1 2 3 4 5 6 6, so there it's 3 cross 6, so we have the six cell. Okay, so the robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid, mark finish in the diagram below. How many possible unique paths are there? So there is a twist. Like you can only move to your you can move to down, that you can take downmost step. Also you can take the right step, means you can either take right or you can take down. So you can go to the right cell, then you can start your journey. Also you can start by going down, means to the down position. Okay, so let's see how we'll solve this position. Let's come to the whiteboard. Suppose take you have a grid. Okay, so I'm taking for explaining, I'm taking this grid. So suppose you have to come to this position and you are at this position. Okay, now you can go either from right, taking the right transition, or you can either take the down transition at any point particular cell. Suppose you are in this cell, you can also you can only take this way or this way. So there are total 2 transitions that you can take at particular position to reach the desired location. So at each cell, after going to each cell, you can only take 2 transitions in 2 ways, and either to left, either to right, or either you can go by down. Okay, so we can solve this solve this problem through recursion. How? if I draw, like I'm drawing the recursive tree so that for your understanding, you will get to understand more through that recursion. I'm clearing this wholly. So now take, you are in 0, 0 position. I'm drawing the grid. Okay. Now you are in this 0, 0 position. Okay. Now over here you are. Okay. So as I mentioned earlier, that you can take two transitions, means either to your right or either to bottom. Okay, so you can go either bottom or either can take like your right one step. So like there are total altogether two ways. If in some interviews they can ask that, tell me the total number of ways you can reach that position without drawing this thing, without mentioning any recursion or something. Direct tell me that, like in most of the interviews I've seen from most, I am talked, I discussed with various interviewer, means the candidates who gave the interviews, and they told me that in most of the interviews they have asked that they are not told to just explain the solution. They are told that in total number of ways, tell me the total number of ways to reach that position. So that time they get little like means they got little confused at how can it. So simply you have to take that, if I have this grid, so there are only two ways. So you can take two transitions, means one is suppose this down path or a right transition. Okay. So if I came to this down path, this is suppose this 0th cell, this is 1 cell, 0, 1, 2. So I will call each recursion calls in each state. So these are basically what? Basically, these are recursion states. So when I'm in the particular state, I can call the recursion function over this, and recursively I can calculate that up to the when I reach the state, I'll just return it value, and this function will return some value and this function will return some value. So the left transition plus the right transition will be my answer. So when the interviewer asks this type of question, you will tell that if there are n ways to go down, okay, and m ways to the right transition, so it will be n plus m. Okay, so n plus m ways will be my answer. Okay, and as you are like calling every time you are going two ways, so it's going to be a in a exponential way. Okay, in an exponential it can be, so the time complexity will be exponential, and in the further next I'll tell the brute force solution where it will be in the quadratic, that I'll decompose the time complexity into a quadratic time complexity. Okay, cool. Yeah. So now we can take, like as I told that you have to two transitions. So I will tell the intuition behind everything. Okay. So let's get started. Yeah. So now I'm clearing it. Yeah. So at first we are in this 0, 0. Okay. We are in this state. Consider each and every position as a state. Okay. So this is our initial state, that is 0, 0. Okay. Through recursion, recursion will bring back the total number of ways, and I will simply return that answer. Okay. So now you are at 0th position, 0, 0 position. So you have your left way and your bottom way. Suppose you take the bottom path, then you will go to simply 1, 0. That is this position, 1, 0. Okay. And if you take the right transition, you will go to, this is 1. So the 1, 0, 0, 1, sorry. So 0, 1, this cell. Okay. Now this state will, at each state of this kind of state, they will call the recursion function. So at each state, it will call a new recursion function. Okay. So like we are currently like in this, we take this step. Okay, fine. Now, what are the ways, other ways I can take? Either I can take 2,0, means either I can go down, as I told that at particular position, at any initial particular position of the cell, any state, you can consider any state, I can take two ways, at least on my right, on my bottom. Okay, so there are two ways, like I am my bottom, I can go bottom. If I go bottom, that will be 2,0. So it's overlooking the bounding condition, it's exceeding the bounding condition. So we can also getting that it will be our base case, right? Because our base case will be right if we are exceeding our maximum row limit or column limit. Okay, I will simply return back, right? Yeah. So when it will not occur, it will return 0. So this recursion, after recursion call, will return 0 to this recursion. And over here I can go like over this cell, this one, so it will be 1,1. Yeah, I can go to the state because it is valid. Okay, fine. So when I read this particular state like 1,1, then I have also two ways, that one to go to this cell and another is down. So if I go down, okay, so it will be 2,1 and it is again exceeding the bounding condition. So it will not occur. It will again return 0. Okay. And again, like as in the right state, we are reaching 2. So ultimately we reach to our final destination and it will return 1. So you can see that here are the two base condition that we are looking of. Like for the recursion, you have to like stop the recursion call at particular moment. So there should be a base condition for that. And over here, the base condition is like when you reach the particular exceeding, the first one is like if you exceed a particular row or a particular column, then it will return back simply. Or if you come to a desired cell, like you can say like my desired cell was this final position, I will return 1. So this function will return 1, this function will return 0, so 0 plus 1. So this function will get, this state will get 0 plus 1 means 1, and this will stay as you can see that this is exceeding the condition, so it will return 0 simply. So from this two state, I'm getting 1 plus 0, that is 1. Cool. And at last, when from my left state, from my left transition, means from my down transition, when I initially start, when I go, first I go to down and then I go to like there are two ways, like right transition and down transition. So when the down transition, through my recursion will return 1 by calculating this whole thing. Okay, cool. I think it's getting a little messy. Sorry for that. So you guys understand now. So like what I'm trying to telling you that through recursive calls, it is returning 1. Okay. Now comes, I'll solve the right transition one. Okay. So you guys are clear with now to the how I'm getting the base condition, how the recursion works, and what is the intuition behind the recursion, how is returning each and every, after going to each and every state, what is the bounding condition, what are my exiting condition, exceeding condition. So yeah. So now we can see, I'm just clearing, just take this side for now. Okay. Just forget this this transition. So now condition now take for this right transition. So I have to delete this also. So I'm drawing new cell. Okay. So if I try to delete that, okay. So this is my 1, 2. Cool. Okay. So I'm talking of this transition. So now you are particularly in this position, you are starting with the right transition. Okay. As there are two ways that you can go down and right at first. So I'm taking calculating for this right transition. So from the down transition I am getting 1 that is already stored. So what I'm getting, so as I told that n plus m ways means the left transition plus the right transition ways. So it will one plus the value that we'll get from this recursion. I'll simply add it and I'll return it to the main function. Cool. Yeah. Okay, nice. So now we can see that we are particularly to this position. Okay, so particularly as same like the previous one, we can either go this or this direction. Okay, so if I'm suppose I have to delete the whole tree only, otherwise it will not work, it will look very messy. So I'm drawing again like, yeah. 0 1 2 0 1. Cool. So now I'm just drawing the like recursive tree for the left one with the right transition on. I'm not drawing that because it will look messy. So that consider that from the previous solution I got 1 from the left part. Okay, from the left part I got 1 ways. Okay, so now particularly we are in this position, that is 0 comma 1, like we are in 0 comma 0 PLC, so 0 comma 1. So as I told, there are 2 ways, that is down and right. Cool. So if I goes this way, it will break. So it can go to the bottom, that will be 1 comma 1, or it can take 1 comma 2, 0 comma 2, sorry, 0 comma 2. This is 0 comma 2, this is 1 comma 1. So let's calculate for this 1 comma 1. So through 1 comma 1 I can again take this step and this step. This step will not consider because it is exceeding the bounding condition, so it will not happen. 2 comma 1 will not occur. It will, as we are exceeding the condition, bounding condition, so it will be return 0. Then we can go to right. So right is like 1 comma 2. So yeah, we have reached the destination. Cool. So it is again reaching the condition, bounding condition, meeting the bounding condition. So it will return 1. So from 1 comma 1 total gets 0 plus 1, that is total 1 ways. So this part we can solve in 1 ways. Okay. Now we are looking for this one. So again, for same like other thing only, we can go to the left, right and down. But this step can't be taken because again we are exceeding the bounding condition. But here we are meeting the bounding condition, so it will return 1. So this 1 comma 2, like this one will return 1 as we are meeting the condition, at reaching the like destination, so it will return 1. And this will not work. This will means 0 comma 3. Suppose we are over here, so it will not return anything because it is exceeding the condition, so it will 0. So total altogether, this will be 1, this will be 2, this will like this is returning 1, so 1 plus 1 2. So altogether, like from the left, like from the down transition we get 1, so it is 1 plus 2 is total 3 ways. Okay, cool. So through that we get that total in 3 number of ways we can reach to the final destination. Like if we calculate in normal way, we can see we can go to the down. First take the down, I am taking the down transition, is D, then I'm taking right, then again taking right. So this is one solution, down, right, right. Another solution that I am taking will be like right, right, down. So right, right, down. And the last solution is right, down, right. So right, down, right. So you are getting that? Cool. So we are getting the whole solution. Fine. So there are total 3 solutions as we like get from that recursive tree, like total it gives 3 ways. So you can see that 3 solutions will be like this way. First it will go down, right, right. It will be right, right, down. And last one will be right, down, right. Okay, cool. I guess you guys, what I'm trying to telling you guys, so you are getting it. Okay. So you are liking this. So please, if you like this, like, please subscribe now and also like my video. So yeah, so this will take near about the exponential time complexity. So now the interviewer will surely ask that please optimize it. So how will you optimize it? So we can optimize it to a quadratic time. How we can do that? Think of that. Pause the video and think for a while. Okay, so if you get the idea, so if you're going to a right approach, then you can think of the DP, okay, dynamic programming. How? Let me draw the recursive tree again. Cool. I'm clearing up this thing. So this mess. Okay. So as the initial position, you were at the 0, 0. So you take 2 transition, that is down and right transition. Cool. Yeah. So you are taking 1, 0. Then you are taking 2, 0, but it is not validating. Cool. So now you are taking 1, 1. Cool. Now you are taking 2 ways. So this way will not work. 2, 1 will not work. Cool. 1, 2 will work. Now again we are taking the right one. This is 0, 1. Okay. This is 1, 1. This is 0, 2. This is 2, 1. It will not take 2. So over this, I can take 2 ways, like 1, like from. So it will be 2, 1 ways, and one is 1, 2. So 1, 2. Now it will be 1, 2 from here. It will be 0, 3. So it's exceeding. Okay. So now we can see that when we are coming to this position, okay, this is returning 0. Okay. This is returning 1. So if we use a dynamic DP table, DP hash table, so if I'm taking, first I'll initialize my DP table with -1, -1, -1, everything -1. Okay, everything consider -1. Okay, so now at 1, 1 position, we can see that we are storing 1. So particularly when I again for this state, for this transition state, I will call 1, 1. Cool. I will call 1, 1. Means I'll call this state. From this state, I'll call 1. I don't need to do an extra recursion call, because I'll simply check the DP table and see that 1, 1 is present in the DP table. I'll ask, hey, DP table, do you have 1, 1? Do you have any value 1, 1 over there? Do you have any value for that? Yeah, I have. So I will simply assign that 0, 1 with this. Like I'll return this thing. Okay. Again, so we can see that we have some optimal substructure command. Means there are some sub properties we are overlapping at each recursion. Like when we are at 1, 0 position, we are performing the recursion call, then that state is also calculating this thing. And when next time when I'm in this 0, 1 state and I am calling the recursion call, I'm using the recursion call, that time also we are calling this same thing. You are calculating the same thing. So why need to do some extra overhead, we can simply check the DP table. I can see that, yeah, we have that thing. Okay, so fine, we can take that. We simply return that. Okay, so for that reason, we use DP, right? So now everything will be same like the previous one, but the extra thing is that we'll store each and every state, each and every particular state recursion calls value in a hash table, and see, like if we have reached there, so we'll not simply didn't call that particular state for the recursion, we'll simply return that value. Otherwise we can call the new recursion for the state which have unvisited, which was previously unvisited. Cool. Yeah. So this is the simple solution for both brute force and optimal one. So this will take a quadratic time solution. Like there are n into m ways will take, like n is number of rows and m will be number of columns. So it will take big O of n into m. And in the previous solution, you can see that it will going to go, it was going to in a exponential time complexity. Cool. So now it will take only quadratic time complexity. So if you tell these two ways to the interviewer will satisfied with the solution. You can, if the interviewer tell you to code it, and the code is very easy, I'm not doing that, so you can get in any online source. So the main thing or in an interview is not to just to code. You have to just tell the interviewer, has to explain the logic, you have to explain each and every intuition behind the logic. So as I'm telling, I think you guys like get to understand the logic behind every recursion calls and how it's taking place. So like if you get these questions in the interview, I think as one of my subscriber, you can answer this question with very ease. I guess I'm expecting from you guys, please rock the interview if you get this type of question. So thank you for watching this video, and like if in future I'll also like make videos upon this interview questions, and side by side my hiring challenge, coding challenge questions are also going on. Coding series was side by side is moving on. So like in each week I'll upload 2 to 3 videos. So for that, like as the interview season is coming in the front, so you will get help from these videos. Like this will revise your concept, it will clear your concept, that the way I'm like telling you, explaining you. So hope you guys like the video, have understood the concept behind that. And if you like the video, please subscribe to my channel, like the video, share with your friends, because sharing is the must, because it will support me. Like I'll get motivated and make many videos. So please support me, and hope till then